Hello everyone. In this video, we are going to learn about Coulomb's law. So we already have a basic idea and understanding about what electric charges are and how they interact with each other, right? We know that if we are going to have like charges, they are going to repel each other, and if we are going to have unlike charges, they are going to attract each other, right? What are these repulsion and attraction actually is? They are simply forces acting between the two charges, right? Now, the Coulomb's law talks about force acting on a charge due to other charges. So Coulomb's law helps us to measure the force which is acting on a charge due to other charges. And this Coulomb law is particularly applicable only for point charges. This is applicable only for point charges. Now, what is point charge? So does point charge simply mean that these charges are very small? Not exactly. Let us draw two charges here, like this. And let's say the distance of separation between these two charges to be r. Let the radius be this. This is charge q1. This is charge q2. Now, how can I say whether the charge q1 is a point charge or not? You can say a charge is a point charge if the charge is very small compared to that of the distance of separation between the two charges. That is, in this case I can say q1 to be a point charge only if my r1 is very small than r. Similarly, q2 is a point charge only if r2 is very small than this r. Okay. Now, to have a better understanding, consider the charges to be sun and earth. Okay, we can definitely say earth and sun to be point charges because the radius of the earth and the radius of the sun is very small compared to the distance of separation between the sun and earth. Obviously, for us, if we look at sun and earth, they are very big in size, so we might not consider them to be as a point charge, but they are point charges because their radius is very small compared to the distance of separation between them. Okay, now we got a clear idea about what point charges are. Now let's move on to what Coulomb's law tells. According to Coulomb, the force which is acting between the two charges depends on, number one, it is directly proportional to the product of the charges, and it says it is inversely proportional to the square of the distance between them, and it says the force depends on the medium between the two charges. Now, the first one is understandable because the force will be more if the charges are going to be more. More the charges, more repulsive or more attractive it will be, right? Similarly, the second one is also understandable because if you are going to have larger distance between the two charges, then the impact one charge has on another is going to get reduced. Right? Compiling all these three, we got the force, electrostatic force between the two charges to be this. Here, this K is proportionality constant, and this proportionality constant is not a universal constant. This is not a universal constant because this constant K is going to be different for different medium. It is different for different medium. This is the one which contributes to the dependency of the force on medium between the two charges, and this K is given by 1 by 4 pi epsilon. This epsilon is the permittivity of the medium. It is the permittivity of the medium. To understand permittivity, we need to have some basic understanding about electric field. So we will deal with the permittivity in later parts of the chapter. For now, we need to understand that this permittivity is the factor which makes the force to be dependent on the medium between the charges, right? Now, if the charges are kept in vacuum, then my K is written as 1 by 4 pi epsilon naught, where this is permittivity in free space, and the K value is 9 into 10 to the power 9 Newton meter square per Coulomb square, and the value of epsilon naught is given as 8.85 into 10 to the power minus 12 Coulomb square by Newton meter square. These values can be useful when we are dealing with problems. Now, let us understand how the force will be different when we are keeping the charges in the vacuum and in the medium by comparing the values. Okay. Now, comparison of force in vacuum and in medium. Okay. So my force in the vacuum is going to be 1 by 4 pi epsilon naught Q1 Q2 by R square. Now let us consider a medium where its relative permittivity is given by epsilon by permittivity of that medium to permittivity of free space. Okay. Then my force in that medium is going to be, we know this is the formula, and from this equation we can make force to be this. From 1 we can observe all the terms to be exactly same as F naught except this term. So I can write my Fm to be F naught by epsilon r, right? So what does this term states? What does this term tells me? It tells that my force in a medium is equal to the force in vacuum reduced by a factor of dielectric constant of that medium. So we can observe that my force in vacuum is going to be greater than my force in the medium, because the force in the medium is getting reduced by a factor of dielectric constant of that medium, right? Now let us try to understand the next topic, which helps us in calculating the force acting on a charge if more than 2 charges are present in a system. Okay, so we are going to learn about superposition principle. Superposition principle. Now let us say I have charge Q1, Q2 and Q3. Now find the force on charge Q1. How will we do this? Simply, since force is a vector, my force on charge Q1 is going to be vector sum of force on charge 1 due to 2, force on charge 1 due to 3. This is what my superposition principle states, that to find the force acting on a particular charge in a system of charges, then it is equal to the force on the charge due to all other charges as a vector sum. Okay. Now let us say I have n number of charges. I have so many charges like this, n number of charges. Then my force acting on charge 1 is going to be F12 plus F13 plus F14 and so on till F1n. So this is my superposition principle. Now let us solve two very basic numericals to have a better understanding about the theorem which we studied now. A charge Q is divided into two parts and separated by a distance such that the force acting between them is maximum. Find the value of charge of divided parts. So this is my question. So what am I getting from the question is, I have a charge Q which is divided into two parts. Let's say this is x and this is Q minus x. Now the force which is acting between these two, if I am going to separate them by a distance r, is 1 by 4 pi epsilon naught x into Q minus x divided by r square. So this is equal to Qx minus x square by 4 pi epsilon naught r square. This is my force. Now they are giving me a condition that my force is maximum. Here we can observe that my Q is going to be a constant value which is fixed and my R is also fixed. The only unknown value is, the only value on which my F depends now is the X, right? So let's say I am plotting my force with respect to X and I am getting something like this. This is the maximum, right? Now what special characteristic does this maximum point have? If I am going to draw a slope on this point, my slope is 0, right? We can observe the slope is 0 for maximum point. So slope is simply dy by dx, right? Here in this case my slope is df by dx, so that is going to be equal to 0. So I have to differentiate my force with respect to x and equate it to 0 because my force is maximum, right? So if I am going to do that, I will get Qx minus x square by 4 pi epsilon naught r square equal to 0. This implies I can take the constants outside and taking the constants to the other side will get only 0. So differentiating this with respect to x, we get Qx Q minus 2x is equal to 0. So I can see my x is Q by 2. So the two parts are Q by 2 and Q by 2.